Now the generating function of the geometric distribution. I'm sure by now everybody knows how to find the generating function of geometric. You just sum up the geometric series with s to the I and the mass function. Instead, I'm going to do something else here. I'm going to show you a probabilistic way of doing it. So let's imagine what's going on with geometric. And I'm going to consider the pessimistic geometric first. Pessimistic geometric P. What is the pessimistic geometric P? Is the waiting time, the number of failures before the first success. So it's going to be, suppose I have a few failures to start with. Okay, and eventually I have this success here. So I'm happy. And then the geometry, pessimistic geometric is this length. Okay, so that's the pessimistic geometric. It could be 0, 1, 2, and so on. In this picture it happens to be 4. Okay, so let's find this generating function. So what is it? Now, with probability 1 it's finite, right? The probability that I never get a success, I'm assuming P is strictly positive here. The probability I never get a success is 0, so it's a proper random variable. And so if I want to find the expectation of s to the x, then I can condition on the first success or the first failure. So I could say, is the expectation of s to the x, given that x is 0, well, let's, yes, times probability x is 0, plus the expectation of s to the x, given that x is non-zero, it's strictly positive, times probability is strictly positive. Okay. Now, the first part is easy, because when x is 0, then s to the x is 1. So this is easy, this is 1. The second part is much more interesting. So x is positive. The number of failures before the first success is positive. In other words, I know that my first trial, this event is exactly the same thing as saying that my first trial failed. Okay, I'm gonna need a positive number of failures before my first success if and only if the first trial failed. So now I know that this happened here. Now I'm here and I'm looking into the future. What can I say? What can I say? Well, the thing I can say is that x, given x is positive, is one in distribution is the same as one failure, this one here. And now looking into the future, what do? I start doing my experiments and I count the number of failures before my first success. That's exactly the same scenario as I started with. So I'm exactly doing the same thing as initially. I'm waiting for the first success and count the number of failures before that for pessimistic geometry. And therefore in distribution, I have the same scenario as one wasted trial plus another pessimistic geometric random variable. Okay? So that's what I'm going to use here, because then I can continue with 1 times the probability that x equals to 0, which is of course an immediate success, that's P. The probability x is non-zero is an immediate failure, which is Q. Q is 1 minus P. So I'm going to say 1 times P here. Then I'm going to write expectation of s to the 1 plus x without any further conditioning. The conditioning did its job. The conditioning made a 1 plus x out of x. So instead of x, I have 1 plus x. But that's it. I don't need this conditioning anymore. Times this factor q at the end. And so what I find is actually quite nice. It's p plus q times a factor of s, the first power of x, of s, which is not random, is coming out. And I'm left with expectation of s to the x, which is exactly my original generating function. So now I have a nice equation for my generating function. This is the right hand side, this is the left hand side. I can solve it, and P of S is going to be, so let's arrange all the P's to the left. On the right I have a parameter P left, on the left I have 1 minus QS, and that's my generating function for the pessimistic geometric. Okay, how do I make an optimistic geometric out of it? Optimistic geometric of parameter P. Well, the optimistic geometric, call it Y, is one more than the pessimistic because it counts the number of trials needed for the first success. That's one more. So P of the optimistic geometric at S is expectation of S to the Y, which is expectation of S to the X plus 1, which is 1S, this 1S, times the generating function for X, which is the pessimistic geometric. Okay, it's just the thing we had up here. So that's going to be SP over 1 minus QS from here. So that's the generating function for geometry. Okay, I'm not going to do the expectation and the variance of it. Everybody now can do it. Take the first derivative, plug in s equals to 1 for the mean. Take the second derivative, plug in s equals to 1 for the second factorial moment. Transform it out into a variance. We've done that a couple of times. I'm not doing it right here. Homework, do it.